Hello, welcome to this video of the classics. Today we are taking a look at the number 10, critère de condensation de Cauchy. So the criterion of Cauchy to condensate sequences. So may U of n be a decreasing positive sequence. We write for n in, in integers, in integer, big U n and v n, the partial sum. So the partial sum this and this one with 2 to the power n, u of 2 to the power n, so it's kind of complicated. We want to show that for all n in an integer, we have this inequality here, and then we'll conclude on the nature of that, and then on this one as well, and we'll see that they have the same nature. Now may alpha be superior to 1, so alpha that is here. We'll try to find the criteria convergence of Riemann series back using that. So let's go to exercise 10, 10, 10, 10, 10, 10. 10. Critère de condensation Cauchy, so we've got our two sequences. So un is decreasing. Yeah, un is decreasing. So I set u to the 2n, so the same sequence except that there is not the 2 here. So that's the sum between k equals 0 to 2 to the power n of the un. So it's inferior to every term of this sum. So basically what I just do is I just develop every term, and this is inferior to u0 plus vn, because it's this. Yeah, it's this. So we are getting this because when you develop, you'll get un plus un1, un2, un3, and you're doing this inequality where un2 plus un3, since un is decreasing, you get this. So that's it. Now we know that Vn over 2 is 1 over u1 plus u2 plus 2 u4. So in the reverse of this thingy here, we're going to do the same inequality. So this part keeps being the same, but we'll approximate the 2 plus a4 as being u4 plus a5, and u2 being hold on, u2, yeah, u2 stays u2, and 2u4 becomes inferior to u3 plus u4 by the fact that un is decreasing. Okay, that's it. So we get this inequality here. Okay, and then for n we get this inequality. So maybe I wasn't clear enough, but basically since it's decreasing, you are taking some terms independently, and you are majorating by a bigger term. So yeah, since 2u2 is u2 plus u2, but since it's decreasing, it means u2 is over u3. And you do the reverse step here because there is a 1/2, so that allows to do this comparison here. So you get this thingy here. Okay, so this converges if un has an upper bound, because this is just the same thing, since the convergence is in plus infinity, so this converges if, like, it's the same thing. So if this has an upper bound, since it's the partial sum, but with 2 to the power n, and this is if and only if u 2 to the power n as an upper bound, which is the same thing as Vn as an upper bound. So it's the same thing as saying that this converges. If alpha is superior to 1, so the sequence u is equal to 1 over n alpha decreases, which is normal, positive, and the condensation criteria can be applied. So the Riemann series, the sum of 1 over n alpha, converges to 2 to the sum of 2 to the power 1 minus alpha to the power n by what we used before. So it converges because we have the same thing as 2 to the power 1 minus n alpha is between 0 and 1, so we found out the criteria. Well, we used the criteria. So that's it with found Riemann. If you have any question, feel free to ask them in the comment. I'd be glad to answer them, and bye. Thanks for watching.